Picture a thermometer stuck at its top mark. The display reads greater than 100 degrees and stays there no matter how much hotter the boiling pot gets. The number no longer tells you the temperature. It only tells you that the actual value exceeds the device's range. That's the simplest way to think about semantic limits. They are the places where data stops being an accurate representation of the thing it's supposed to describe. Limits don't mean the data is wrong in the arithmetic sense. They mean the data has stopped carrying the meaning you expect. Let me say that again more plainly. Data can be perfectly well formed and still be meaningless for the question you want to answer. Semantic limits are the boundaries of usefulness. What kinds of limits are we talking about? There are several, and they show up in different parts of a data lifecycle. Measurement and sensor limits. Devices have precision, range, calibration, and latency. A sensor that measures wind speed to the nearest 0.1 meters per second has a different semantic quality than one that reports integers. A camera that saturates in bright light stops reporting useful pixel values. These are physical limits, and they directly constrain what conclusions you can draw. Representational limits. Sometimes the data model itself cannot express what you care about. A single Boolean field is active cannot capture why a user is active or which features they used. An integer code might represent dozens of categories, but it can't capture nuance like tone or intent. When your model compresses complex reality into a narrow representation, you've hit a semantic limit. Sampling and coverage limits. If your dataset only covers desktop users, it does not represent mobile behavior. If you only log business hours, you don't see overnight patterns. Limited sampling creates limits on where you can safely generalize. Temporal limits. Data is a snapshot or a stream. It ages. A schema or a metric that made sense last year may not make sense today. Historical data may reflect past processes, not current reality. Time creates shifting limits. Granularity limits. Aggregation hides detail. A weekly average can't show hourly spikes. Saying average temperature flattens extremes. If your question needs finer detail than your data's granularity, your conclusions will be limited. Semantic scope and conceptual limits. Some concepts are inherently fuzzy. Customer satisfaction, engagement, or trust are broad ideas that map to multiple proxies. No single metric fully captures them. The data proxies you choose impose a ceiling on how faithfully you can measure the underlying concept. Legal, privacy, and policy limits. Regulations may prevent you from collecting or sharing certain attributes. Masking or anonymization changes the data's semantics. A hashed identifier is no longer a direct key to personal identity. These limits matter because they change what you're allowed to infer. Modeling and inference limits. Machine learning models can interpolate within the domain they saw during training. They rarely extrapolate reliably beyond it. If your production data moves into regions your model never saw, predictions become guesses, not evidence-backed inferences. Why pay attention to semantic limits? Because ignoring them leads to confident-sounding but fragile decisions. You might wire a dashboard, ship a model, or automate a process that seems to work, until a situation arises that sits outside the data's expressive territory. That's when silent failures happen. Misattributed revenue, biased models, or incorrect safety alarms. Semantic limits also shape trust. If your team understands what the data cannot tell them, they avoid overclaiming and design safer fallbacks. Limits make you conservative where you should be, and bold where the data actually supports it. What can you do about them? A few practical steps that work in real teams. Document limits as metadata. For every dataset or API, include entries for range, precision, sampling frame, update cadence, known biases, and what the data doesn't capture. Write a short, do not use for note. Metadata that lists limits is far more valuable than a terse-type declaration. Make limits machine-readable. Encode minimum and maximum values, null meaning, units, sampling rate, and canonical source in schemas and contracts. This lets pipelines and validation tools check for out-of-range conditions automatically. Propagate uncertainty and trust levels. Don't return a single number where the precision is suspect. Return confidence intervals, quality flags, or an explicit saturated marker. Let consumers see the certainty instead of assuming it's perfect. Test beyond the happy path. Run tests that intentionally push inputs to their extremes. Overflows, saturations, missing sources, and unusual time zones. These tests reveal semantic brittleness early. Model the coverage. Keep a simple inventory of what populations, geographies, or times the data covers. Use that to gate analyses. Do not generalize outside these cohorts without additional evidence. Design graceful degradation. When data hits a limit, choose safe behaviors. Pause automation, surface an alert, use a fallback model, or route the case for human review. Silent substitution is the worst option. Train users and consumers. Add short guidance in dashboards and documentation. This metric is not reliable for small sample sizes. Do not compare values across regions without currency normalization. These tiny notes prevent big mistakes. Track provenance and transformations. Limits often arise from upstream transformations. Resampling, rounding, or anonymization. If you can see the chain of transformations, you can reason about which limits were introduced where. Use explicit contracts. When data crosses a boundary between teams or systems, the contract should state the limits. Contracts should include both what is guaranteed and what is outside the guarantee. To wrap up, semantic limits are not bugs to be fixed once and forgotten. They are facts of life. Data systems are always approximations. The meaningful work is to know the nature and location of those approximations, to encode them, and to design systems that notice when they've been exceeded. If you leave this video with one habit change, make it this. Add a short limit section to every dataset README and every API contract you publish. 1 or 2 lines describing the range, what it doesn't cover, and what to do if you see the edge. That pays off far more than a week of frantic debugging when a limit is reached. Thanks for listening.